Welcome to TWIN BUSCH Germany, your competent specialist since 1997 in professional vehicle workshop equipment. With a corporate headquarters in Germany and 9 other branches in 7 countries, as well as over 40 sales partners worldwide, we are one of the leading manufacturers of vehicle lifts, wheel balancers, and tire changers. Welcome to TWIN BUSCH Germany. I will now show you our headlamp tester, TW SWE-D. We will now show you how the device works in principle. First of all, we will check whether the headlight adjustment device is at the correct angle to the vehicle by using the band laser. The laser must intersect 2 symmetrical points on the vehicle. In our case, for example, the tips of the bonnet. We will then fix the angle again using the foot pedal. Now position the headlight adjustment device in front of the headlight using the targeting laser. By using the laser, the adjustment device can be positioned in front of the headlight very precisely. A highly precise measurement recording is thus possible. At this point, it must be also mentioned that the distance between the headlight adjustment device and the headlight must be between 30 and 50 centimeters. We now need the angle of inclination for the vehicle headlights. This value is usually indicated on the door frame or also directly on the vehicle headlights. In our case, we find the value under the hood of the car. The angle of inclination briefly explained. Starting at the headlight, we determine a distance of 10 meters and draw a horizontal line starting from the middle of the headlight. For better visibility, we will change the proportions here. The distance between the upper edge of the light beam and the horizontal line is called E. This is the value that is appropriate for the vehicle and that must be set in the headlight adjustment device. As an alternative to the E value, the inclination can also be indicated as a percentage, as in our case. This results then from the formula of the height difference divided by the distance times 100%. First of all, we select the desired type of vehicle. In our case, the automobile has automatic inclination adjustment for the light beam. We now set the given 1%. Notice that the value must always be set with a negative sign, even if it is printed on the automobile without a minus sign as in our case. Lights on. The measurement for the left low beam can be started after switching on the headlights. Start the measurement. The SWE-D is equipped with an SLS, self-leveling system. The device can compensate for floor unevenness of up to 10%. A compensation of only 3% is legally permitted. Therefore, no special floor leveling or track system is necessary. The device automatically recognizes the deviation from the baseline and displays whether the deviation is within the legal standard. Then we repeat the measurement for the right headlight. Activate the laser. Align the device with the headlight using the laser. Start the measurement. Note the luminous intensity of the headlight as well. In general, this may differ by a maximum of 20% between the right and left side. The measurement is thereby concluded. Here we have a brief overview of the functional scope of the SWE-D. At this point, it should be also mentioned that the SWE-D can be delivered with optional ASA network capability. Individual settings can be implemented for every vehicle and every measurement within the vehicle settings menu. All global adjustments are carried out in the options menu. For example, the applicable measurement standards, the printer settings, Information on your workshop or details on measurement value assessment. The headlight adjustment device SWE-D by Twin Busch is suitable for all common headlights, such as, for example, xenon, LED, LED matrix, laser and classic halogen headlights. The device is delivered with a fitted protective cover.